Welcome to an algebra tutorial video learning about linear equations. We've been going through a few videos about perpendicular lines and understanding how perpendicular lines work with our ideas of slope and linear equations. In this problem, we're going to do a little bit of geometry in perpendicular lines. So we're given a shape right here, and we want to prove that quadrilateral is just a word for four-sided shape, we want to prove that it is a rectangle. So we're kind of we're using some coordinate geometry which applies algebra and graphs and points to understanding shapes a little bit better and proving shapes and understanding definitions of shapes. Alright, so where we want to go in a problem like this is if I want to prove it's a rectangle, what do we know about a rectangle? A rectangle has two things. So opposite sides have to be equal. So I could go through and find, well, what's the distance of each side? Or I also know a rectangle has to have each corner be a 90-degree corner. I'm going to go ahead and draw that in. If I can show that they're all 90 degrees, that's enough to satisfy that it's a rectangle. Well, what do we know about lines and slopes and 90-degree angles? A 90-degree angle is a perpendicular corner, it's a perpendicular lines to each other. So essentially, on a problem like this, all we want to do is find the slope of each side and see if they're all negative reciprocals, see if they're all perpendicular. See about negative reciprocal slopes. So we've got pretty much four different lines to go through. We're going to find the slope of that line, call it number 1, and the slope of that line, 2. We're going to find the slope of this line, or this side right here, we're going to call that number 3, and the slope of that one, we're going to call it number 4. And we're wanting to show that 1 and 3, 1 and 4 are perpendicular to each other, and then 2 and 3 and 2 and 4 are perpendicular to each other. So we have to find 4 slopes and then just see how they all compare. So the slope formula, if you remember, so subtract your two y values, y2 minus y1. We always compare the change in y, and then we compare the change in x values, and we get a nice rate of change going on. So that's my slope formula. All right, let's start with side number 1. Oops, I don't like that color. There we go. Side number 1 right here. So the coordinates of that point, let's see here. So we're going over -7 and then up 2. So coordinates of that point right there. This point is -3 and then up 7. Okay. The coordinates of this point right here are 1, 2, 3, 4, 5, 6, 7 to the right and down 1. And the coordinates of this point are over 3, down 1, 2, 3, 4, 5, 6. All right, so I needed the coordinates of the point to use with my slope formula. Now let's find the slope of this line right here, number 1. So we have 7 minus 2. I'm going to subtract my y values. 7 minus 2, and then -3 minus -7. Make sure you use your parentheses to make sure you're not losing negatives or misapplying negatives. 7 minus 2 on the top is 5, and -3 minus -7 turns into -3 plus 7, so it turns into 4 on the bottom. So we got a slope of 5/4. So we go over 4, up 5. All right, there's one slope. Now let's move on and find the slope of number 2. So in that one, we're subtract my y values. Let's do -1 minus -6. Change in y. Now let's do change in x. 7 minus 3. So -1, the two negatives turn to -1 plus 6. We got 5. And 7 minus 3 is 4. Oh, that's interesting. 5/4, 5/4. If we have the same slope, we actually have parallel lines. So we actually just showed the side number 1 here and side number 2 are parallel. Interesting observation. Let's keep moving along. Let's do the slope of side number 3 now. So that's this one right here. So we're going to subtract these two, kind of find the change between those 2 points. So let's do 7 minus -1. It's my change in y values. Divided by -3 minus 7. So 7 minus -1 turns into 7 plus 1. And that gives 7 plus 1 is 8. And -3 minus 7 is -10. And if I simplify that, 8 over 10 reduces down into -4/5. Run out of room there a little bit. But there we go. We got the slope of that line. All right, let's put one more line to find out here. Line number 4. So this last line, or this last side of the rectangle, I'm going to subtract my y values. So 2 minus -6. Divided by -7 minus 3. So 2 minus -6 turns into 2 plus 6, that's 8. -7 minus 3 is -10, so that one also reduces down. 8 over 10 reduces down to 4 over 5, and it's negative. And now let's compare all 3 slopes. So compare with sides 1 and 3. Are they negative reciprocals of each other? So side 1 is 5/4 and side 3 is -4/5. Well, they satisfy the negative part. One's positive, one's negative, and they satisfy the reciprocal part. One's 5 over 4, the other's 4 over 5. So yes, I'm going to put a check mark here. I just showed that side is perpendicular. And we can go through all the other sides, side 3 and 2. Let's compare this angle. So side 3 had -4/5 and side 2 was +5/4. So yes, those are also negative reciprocals. And we can go down and do the same thing. 2 over 4, comparing these two sides, 5/4, 4/5, one's positive, one negative. So those 2 lines are perpendicular. And we can also show. So we can show between 5/4 and -4/5, each corner is a perpendicular corner. They satisfy the whole idea of negative reciprocals. And we just proved that, yep, because they're all perpendicular, they all have to be 90-degree angles, and this has to be a rectangle.